In this video, I'm just going to show you how you can find the derivative when you have a function of x raised to a function of x. So this is 1 plus x to the x power, and it could have been 1 plus x to the x squared power, or it could have been 1 plus x to the sine of x, or it could be x squared to the sine x power, or x squared to the 1 plus x power. But the point is you have a function of x and the power is also a function of x. Now this does not satisfy any of the rules we have so far, because for the power rule, this exponent cannot be a variable. It has to be a real number. And for the exponential rule, the base cannot be a function. The base would have to be a constant. So actually we don't really have a formula for this, but I'm going to show you kind of a neat little way to differentiate a problem like this and using logs. So the first thing I'm going to do is I'm just going to take the log of both sides. So I'm going to take the log, and when I say log I mean natural log. So I'm going to take the log of y, and then I'm going to take the log of 1 plus x to the x. Now I know I have a log property that allows me to move this exponent down here as a factor, because I have a log property that says the natural log of a to the x is x times the natural log of a. So now I'm going to differentiate both sides. Now you may not, I know I haven't covered implicitly differentiating yet in my videos here, but really this isn't too difficult. What I'm going to do is I'm just going to take the derivative of the natural log of y. Now this would be just like taking the derivative of natural log of u. So when I take the derivative of natural log of u, remember what I'd get? I'd get 1 over u times u prime. Well, I'll just do the same thing with y. The derivative of natural log of y. See, y is a function of x. So I'll just take the derivative of natural log of y, I'll just say it's 1 over y times y prime. And then on this side, I'm going to take the derivative of this product. So I have a product where u is x and v is natural log of 1 plus x. So I'm just going to apply the product rule to this side. So if I apply the product rule, I'll take the x, which is the u, and then I'll multiply it by the derivative of v, so the derivative of this natural log. Well, the derivative of natural log of 1 plus x, remember, is 1 over 1 plus x times the derivative of 1 plus x, but the derivative of 1 plus x is 1, so the derivative of natural log of 1 plus x is just 1 over 1 plus x. So that's the first half of the product rule, x times 1 over 1 plus x. And now the second half of the product rule, I would take the second function, which is natural log of 1 plus x, and then I'd multiply it by the derivative of x, which of course is 1. Okay, so what I end up with here is just x over 1 plus x plus natural log of 1 plus x. And so I'm just going to bring that down here. Now, I wanted to get y prime by itself, but I've actually got y prime over y here, or 1 over y prime. So what I could do here, and I'm going to show you down here, so what I'm going to do is I'm going to multiply both sides by y. So if I multiply the left side by y, then it'll just cancel the y's. And then if I multiply this side by y, it'll just give me a y as a factor. And so if you look over here, you'll see the y right here. So let me get rid of this so you can see it. Okay, so you see the y there. So multiply the left side by y and it'll just give you y prime. Multiply the right side by y and you'll have y times all of this. Now, here's the good news. We know what y is. Y is what we started with. So we know y is 1 plus x to the x. So now if I just replace that y right there with 1 plus x to the x, now I have a function that represents the derivative of the original function. So now I have that the derivative of this original function up here is actually equal to 1 plus x to the x times the quantity x over 1 plus x plus the natural log of 1 plus x. And so that's all there is to it. So that's how you find the derivative of a function of x raised to a function of x.